Hello, this video is for CIS200 Unit 12 challenge work. It's only two questions on this one. The first one is, again, they may be out of order, but the first one is biographical information on Alan Turing. I'll just write Alan Turing. So Alan Turing was a British mathematician and logician whose pioneering work laid the foundation whose pioneering work laid the foundational architecture for modern computer science. In computability theory, he introduced the abstract Turing machine. Go ahead and capitalize Turing machine. In 1936, mathematically defining the limits of what a machine could calculate and proving the existence of incomputable problems. During World War II, his cryptographic work at Bletchley Park led to breaking the German Enigma cipher, famously inventing the electromechanical bombe machine and saving millions of lives. He turned his focus to artificial intelligence in 1950 as he proposed the Turing test. This is a pragmatic standard to evaluate whether a machine could exhibit intelligence or intelligent behavior, indistinguishable, could exhibit intelligent behavior indistinguishable from a human. So essentially, could you be presented with a machine, not knowing it was a machine, like, conversing with it, and then the person it was conversing with not being able to tell whether it was a human or a machine? So that's enough for question one. You can go ahead and save it as a document for your records and then convert it to a PDF and submit it. We'll move on to question two. And this one is, we'll just call this one the Turing machines. All right, read through the question. So we'll go ahead and we'll call this one number one. Um, I'll just label it two-track Turing machine. So I'll call this part logic. So you put string one on track one and string two on track two. perfectly aligned. So we'll list the states. State 1, we'll just dub it scanning. If both tracks match, reading 0 or 1, so both read 0, both read 1, rewrite the same symbols, stay in state 1 and move right. State 2, call this one equal halt. So if both tracks read a blank dubbed B, it means the strings matched all the way to the end. Transition to state 2 and halt as the strings are equal. State 3, unequal halt. So if at any point track 1 does not match track 2, such as reading a 1 and 0 respectively. So like track 1 reads a 0, 1, track 2 reads a 0, or track 1 reads a 0 and track 2 reads a 1. Transition to state 3 and halt. Strings are not equal. So we'll call this single track. So to do this on a single track, you have to place the strings sequentially. The machine must read the first character of string 1, cross it out, remember it using a specific state, cross the tape over the delimiter. So if they're sequentially right, it would be like string 1 asterisk times string 2. In this case, the asterisk or the multiplication symbol is just a delimiter, right? So cross the tape over the delimiter, which is the asterisk, and check if the corresponding character in string 2 matches. It must zigzag back. So it must zigzag back and forth every single character traversing the delimiter, which takes significantly more states and steps. Number 3, so we'll just say standard machine to 2-track. Any problem a standard Turing machine can solve can be done on a 2-track machine by simply ignoring the second track entirely, leaving it completely blank, right? And executing the exact same standard instructions strictly on track one. And now we'll flip it, right? So two track to standard machine. So a standard single track machine, standard right is single track right. So we could go ahead and call this one just standard machine. So a standard single track machine can simulate a two track machine by expanding its alphabet to use composite symbols. For example, if the two tracks hold one and zero, the single track machine treats that specific column as a single combined character, such as this is how it would appear 1 comma 0 inside square brackets, because the single track can represent any combination of the two tracks in a single cell. Its computational power is identical. All right, that's question two, and this one's only two questions. Save it as a document, then convert it to a PDF and save it and submit it. This concludes CIS 200 Unit 12 challenge work. I hope that you found this video helpful. Thank you for taking the time to watch it. Have a great rest of your day.